Good afternoon. I'd like to welcome you to this session. We're going to get started right on time so that we can hear everything that Niels has to say. Let me give you a quick bio on our presenter. Niels has worked with GIS for 30 years, the last 10 at UMass Amherst, University of Massachusetts, focusing on the technology applied to FM. For the town of Amherst, he created a SAG Award winning Enterprise GIS. He has a BA in Environmental History at Northland College and an MLA in MRP at UMass. Niels Cour is a senior physical planner in campus planning at the University of Massachusetts Amherst. Niels, I'll leave it up to you.
Niels, you might want to pick up the microphone.
Okay.
So you can hold it. Sorry, I should have said before.
That's all right. Good afternoon, folks. Glad you could join us here this afternoon. I'd like to give a shout out to my colleagues, Alexander Stepanov, who's our GIS architect. We refer to him as Sasha, which is what I'll say. And really, this is a presentation that he put together for the FME Global Tour a couple of months ago. And but we wanted to share it with you guys, and hopefully I'll be able to do it justice. But he's the real brains behind the operation. For those of you who don't know UMass Amherst, we're located in the wonderful Connecticut River Valley in western Massachusetts. We have finally sort of crossed the 30,000 student threshold. I know it's not nearly the size of Ohio State, but big, certainly big for New England. Have about 6,200 employees. We have about 13 million square feet of buildings and 200 major buildings and about 1,450 acre campus. So what I'd like to do today is sort of give you a little background and talk about the evolution of how, well, first of all, let me, excuse me. I'm going to talk a little bit about the evolution of FME applications within our organization. Then I'm going to take you through sort of three applications of that on how we use it. But I first want to ask, how many folks here know FME technology or use it? Okay, got a few, but for those of you who don't, it's Extract, Transform, and Load program made by Safe Software, a wonderful little company out of Vancouver, Canada. And it allows you, it's basically a giant two-way pipeline for data. You can take 400 different, they're up to 400 different data types now that you can pull out, you can manipulate, transform, and then load into 400 other different data types. So it's a pretty amazingly powerful software program. And I remember giving a talk about FME last year. They had 300 different data types. So they're constantly improving and expanding the technology. I have to give a shout out to Mike Parkin at MIT because it was a visit with him about 8 or 10 years ago when Sasha and I stopped by, and he told us about this wonderful little program called FME that they use to take their floor plans and turn them into GIS. Sasha came back to our office, started playing around with it, and now he uses it for just about everything, including a lot of GIS operations that he never opens up ArcGIS for. He just does it all right in FME. So it's a pretty amazing technology, and that's why we really look at it as a disruptive technology, because it just makes so much sense to use this. Doesn't cause any conflicts with anybody, and we've really sort of started from simple applications to now becoming very complex and really important piece of how our workflows go. And gives you the ability to complete solutions and cover a whole spectrum of different things. So as I said, we started out simple, just doing simple data conversions. I want to take this little piece of text from this layer in the AutoCAD drawing. I want to take the polylines from assignable floor space. I want to bring them over. As I'm bringing them over, I want to make sure they're closed polygons. If they're not closed, use these algorithms to close them. As I'm putting them into GIS, take concatenate that room number with the building number and the floor code and the drawing, and put it into Esri format. So that's kind of how we started. Now we use it for all kinds of different systems, which is what I'm gonna get into as we go on. Sasha was really happy then to find out that Python is completely embedded in the product. And once he realized that he could use the full library of Python scripts that are out there, man, he really went to town there. So you can see that there's a whole lot of different technologies that this piece of software pulls together, and including different kinds of statistics programs, a lot of different stuff. And the great thing is it works with a whole lot of different types of programs. So now I'm going to get into a couple of the different projects that we've been using it for. And one of the biggest that our space management group really appreciates is now that a lot of our all of our deliverables for new buildings are in BIM, being able, it's not just the CAD drawings anymore, it's now the BIM drawings that we got to bring in, but we still use them in TRI CAD as CAD drawings. So I want to talk a little bit about our new physical science building that we're just occupying now over the summer. That also allowed us to do a restoration of our historical West Experiment Station. As I said, the final deliverables were a BIM Revit model of the building, and we need to then take that model and generate TRI CAD floor plans that has a very predefined data layer structure and space layers, and basically then going also from 3D to 2D. So we've got the source is the BIM models of the two BIMs. They're in 3D, and as you guys know, BIM models have a whole lot of complexity, and it's amazing how much data and information is in there. And we're taking that incredibly rich data source and really reducing it down to a 2D CAD drawing with only 25 predefined layers. And we have very strict naming conventions and content types. And I appreciated all the talk about standards earlier this morning. I would imagine with an organization the size of OSU that you really got to have standards. So we do this through sort of two parallel workflows. One on the top you can see is kind of the workflow to deal with the space attributes of the BIM model. And basically, thankfully, FME supports IFC formats, so we basically want to take those space attributes and bring that in, as well as then exporting the CAD floor plans. So I don't know if any of you have seen the interface for FME is actually called the workbench, and it's actually a very nice graphical user interface where on the one side you have all your extractors, and you basically pull one out, put it up there, you draw a line to what you want to do with a transformer that you want to do something with the data you're extracting out of there, and then you're going to send it to the next thing you're going to do with it. So it creates a really wonderful interface to work with because all of your workflows are very clearly documented, and then you can always put a little checker on it, check and see how the results as you're building your workflow. You can always go back and check your results and make sure things are working correctly. So not only do you get a wonderful, easy, intuitive interface to work with, but you get great documentation for your project and what you're doing. So this is the workflow to basically take the BIM drawing and remap it to a CAD drawing. So you're got your files that you're pulling data out of. You're adding the auxiliary attributes to. Then you're sending that to renaming those things and set the floor names and the building IDs to make sure that it matches with our TRI CAD database. And then we had to create a big crosswalk table, because you're going from 72 different layers down to 25. We had to create a crosswalk on, which ones are going to which and map that all out. Then basically make sure that we pull out all the annotation and label management, and then send it to the destination layers, and then fan it out to the building and floor. This is just an example of, you pop open one of the transformers there, and it tells you what's going on. So this is the transformer that basically mapped out that crosswalk table from all the different layers. So you're going from this incredibly complex BIM model down to a very simplified CAD floor plan. And the other issue then was basically creating the spaces, and how do we do that? And basically what Sasha finally figured out was to take these cutting planes and cut through the 3D model so that we could then get the polylines for each of the spaces. So basically, he takes the 3D space objects that we transformed into IFC floors, and then created those cutting planes that were basically 3 feet off the ground, and then sliced through them and put all those resulting polygons into the floors. So here's sort of an example, a graphic example of taking those 3D cutting planes for each floor, the 3D space objects, doing that sort of slice across them to create the cross section, and then flattening them down into 2D. So one of the other things you'll see about FME is that I love the way they name things, like the spatial filter, the dissolver, the donut hole extractor. I mean, when you're searching for the 300 or 400 different, extractors you need, what would you call it? Well, what's it going to do? And that's one of the reasons why we really love this interface that we have here is they just name things what they ought to be named and stuff. So here's sort of a process to basically, dissolve the different components, create bookmarks, define the spaces to dissolve, and then assign, aggregate those spaces, and remove the donut holes. So one of the issues that we found in this particular building was one of the big lab spaces had been divided into a bunch of different spaces within the BIM drawing, but the way we wanted to deal with it in TRI was as one large space. So you can sort of see here how in the BIM model it was kind of all these spaces divided up, and what we really wanted to get to was the far one over there was really just 3 spaces. And this is again the workflow that you did that, where we also had to take into effect that space in the doorway, and where does that go? Because that space actually should be part of the room. So he came up with a whole work process to be able to identify where the doors are, create a diameter around it to capture that space that was within the door frame. And actually this slide more or less illustrates better how to do that, and basically automate this whole process of taking those little tiny spaces in the door and be able to put it into the proper space there. So sort of to summarize this process, it's really about bulk processing, about taking the time, and there was a lot of time and efforts having to think through and set up that whole workflow. But now that you've set it all up, then you can just set it on to run, and it cooks. And so if you set up that general schema and data, then you can just go ahead and get it done. And you want to be fluent and efficient, and FME allows you to do that because it supports 3D operations, and you can easily switch back from 3D to 2D and back again. That's why I said it's really a two-way pipe when I talked about it earlier. And then you can utilize all the different transformers and import rules from different data sources and database. So really you want to try to minimize the manual work and make sure everything is consistent with what you're really trying to do, and set those configuration settings. So we really see, unfortunately FME is not here. We should try to get them here to one of these conferences in the future. I tried to hint that to them, get that message to them at the Ezra User Conference through Sasha. But we see an opportunity for them to create some FME transformers for, BIM to CAD, and to support all the different programs like TRI Archibus, and Centerstone. Fortunately, people are starting to figure out what a big market higher ed is now. Now, this is one of my favorite projects that we used FME for, is how to create a much more easier to use utility map that was available to people. So, like most of you, our utility map is in CAD, and it is not a GIS with all that wonderful attribute information in it. And it's also not that accessible to people. As you see, it's also very complicated. I'm sure all of you have this kind of spaghetti on your grounds, but it's file-based. We've put close to $2 billion into our campus over the last 10 years, so it has changed a lot, and trying to keep up that change has been pretty difficult to do. You know, your only attributes are the text and color. There's a whole backlog of existing survey data. And the biggest part, though, is it's really not a very efficient access for multiple users. And you don't have any search and navigation capabilities. And so, unfortunately, everybody relies on our surveyor. To get information about our utilities, you got to go talk to the surveyor. And he can either get you a CAD file or print you out a map or something like that. And that's not really accessible on a daily basis. If there's a water main break or something, and some of the other utility guys need to get access to the drawing, it's not that great, because they pretty much have to go through the campus surveyor, which is Carl Larson, the CL. What we wanted to do with it was, and what I've been sort of calling for quite a while, is we just need a picture. We just need a picture that we can share with people. Yes, I know it doesn't have all the attribute information, but at least we know where it is. So what we wanted to do then is create a graphic of the utility map and serve that up through our GIS, online GIS viewer, and combine it with our aerial imagery. So, the people can hopefully help deal with some of the rate of change on campus, and be able to have all of those CAD features and everything that was on that CAD drawing, but in an easy, efficient access for multiple users. And then we also harvested all of that text so you could do some search and navigation with it, and then overlay that with our aerial high resolution imagery. And again, documentation, and our online GIS platform is great because it's got a lot of markup capabilities. So, it's a lot about communication and collaboration. And then one of the really cool things about this is the web tiling and indexing. So how did we end up coming up with this graphic? So I had been asking for this graphic of our utility map to serve up for quite a while. And we finally figured out how to do it. So the first thing we did was use FME to basically chop up the CAD drawing into a whole bunch of tiles. And then once we chopped it up into all those tiles, we turned it into a very high resolution raster image. And then once we had all those different high resolution images, then we could cache them and create a mosaic that we could then serve up in our online GIS platform. So we used FME to basically do the chopper, and is that what it was? I think it was something like chopper was the transformer that he used, and prepare all the different tiles together and output all those CAD tiles. And then within FME, it utilizes Mapnik. And so we utilized Mapnik Rasterizer to generate 3 different levels of resolution, depending on what zoom levels you were going to be at. So low definition, medium definition, and high definition tiles. And so that gave us our high resolution raster images that then we used a program called MapTiler to then take all of those high resolution images and tile them together. So, and part of that process, a parallel part of that process, was basically harvesting all the text labels and notes. So to get all the pipe sizes, all of the names and, like pit numbers and things like that. We wanted to harvest all that information so that we could do searches on it. So you can read all the CAD layers at once, get only the texts you want. You can exclude some of the diameters. It's amazing what you can use again through Python and the regular expressions, and it's amazing the definition that you can have when you say what you're looking for out of this drawing and what you want to get out of it. So filter out all the erroneous text and abbreviations and things like that. Set it all up and get the text insertion points, and then put it into a GIS database. So here I'm going to hopefully run a very quick little video that just kind of shows you what we were looking for to get a high definition, quickly to use. This is our online. Uh-oh. Let me see here.
Did we get anything back?
So something might be.
There we go.
I must have hit the cable. Sorry about that.
Sorry, it's a touch. Yeah.
So this is a very simple application of our online GIS viewer, just to really show sort of the speed of display of the AutoCAD drawing. So we create the CAD utilities as kind of an overlay. But you can see that we've cached all these many megabytes of tiles that you can pan and zoom around, so you can just see it as kind of a CAD drawing with no background. But then it gets really powerful when then you overlay that with our aerial photography. So now, and fortunately, it actually lines up, and you can see that the manholes and stuff are all where it's supposed to be. So this becomes a pretty powerful tool. Again, it was just a picture, but boy, have the utility folks really appreciated it. Being able to get access to that in the field. Oh, there we go. So in summary, basically, we went from a vector to a raster. And so, one of our sort of religious beliefs in our GIS group is to be data-centric and format agnostic, and FME is really gives us the ability to do that. So we could also then harvest all the labels and annotation to build, and text to build a search geolocator, and then be able to, and Sasha notes here that the search is one of the most requested features in GIS. So again, where is that electric pit? Where's that steam manhole? And this allows you to zoom there very quickly. And then automate the rendering and rules using Mapnik, which is part and parcel of the FME product. And of course, I know it's coming, but I hear vector files are coming, and that's one of the things that we see would be a real help for us in the future. How are we doing on time? Okay. So the last thing I'd like to get into is sort of using wonderful photos and Box and GIS and FME to sort of pull things together. A few years ago at the Smart Campus meeting out in Santa Barbara, I was really struck by all, people talking about all the sensors that are coming out and things like that. And, we all carry a great little sensor around with us all the time in a smartphone, and the ability to take pictures with, where which direction you're facing, where you are, and things like that. We really, photos are an incredible data source. As they say, a photo is worth 1,000 words. So to be able to harvest that as a sensor is something that we've really started working towards. One of the, Peter Brigham at UMass Lowell turned us on to this wonderful little Ricoh Theta 360-degree camera. I don't know if anybody is using those things. Yes, that's right, and you guys have gotten most of your rooms done now. $300. It's a pretty amazing little device that allows you to, plop it down in the middle of the room, leave, take a picture. Now you got all the information about the room right there. So We were also lucky to have a real technologist in Mark Anderson, who's a real innovative guy who would help us create lots of ways to modify this just using a monopole. But then he created this wonderful cover there, like an umbrella with the things, to be able to stick it upside down into a manhole. So now we could go in and take 360-degree pictures of all the manholes without actually having to go in there. He also, used his 3D printer to fashion the little holders for the calculator that we use to put the manhole number on there, so that the identification of the manhole is right in the picture. He put a little laser on there so we could say this is north, the north wall of the manhole, and then a set of lights that it would illuminate it all. So we were very lucky to have a real special person, putting all that stuff together. And, suddenly now you can go to a manhole, pop the manhole, and within seconds you've got a whole lot of information about that manhole. You can see where all the wires are coming in, where they're all leaving, how many duct banks you still have open. So it's a great little piece of technology there that's pretty cheap and easy. So we also got tasked with doing a big sign inventory, and this is where Box has come in real handy. So our organization supports Box. It's highly secure. It has a lot of flexibility in terms of adding metadata and those kinds of things. So basically, we started taking pictures of all the signs on campus. And then once the person went out and took pictures, so that didn't take long to go around and take all the pictures. Probably one of the biggest time consuming was then coming and sitting down, and you can see on the sort of the right-hand side there, you can set up all the metadata within Box. So now once the person went through and set up all the metadata on like what sign type it was, what was the text on the sign, what all that kind of stuff, now you actually have a searchable database. And that was pretty amazing to be able to have a searchable database, be able to call up different kinds of signs for different things. And we also took the location of the photos, where they are, which way they were shooting. So we had all of that kind of stuff. And between all those things, you could not only get the content of what the signs were, but you could also use then our aerial photography. I mean, the photo triangles aren't as accurate as you want for the sign location, but then you can use our high resolution imagery to locate the actual location of the sign. So the wonderful thing about putting it into Box is then it gives you this searchable database. So this is basically the workflow, is the data collection, taking the photos, putting the attributes in using Box, and then now that you sort of have that database, you can extract that metadata and location of the photos using FME, and then derive the sign locations, like I said, from all those different features, and being able to just put a spot on the map, and then establishing your GIS web services. So one of the nice things is FME can go out onto the web and grab stuff. And that's a pretty cool feature, is being able to create this link. It follows the link and then brings the pictures in and can do something with. So you can see, maybe you can't really see up in the top here, but it can take the paths from the web and grab that data and process it. Oh, here's the better idea of the box that then creates the that metadata for the signs, and then basically then taking that photo table and box file, creating an SQL table for attributes. So really the FME was able to automate the fusion of images into before and after. We can automate the generation for the 360-degree photos, and automation. That's Sasha did his PhD in operations management, and I often call him the optimizer. So the lessons from this, in conclusion, are that the cloud storage is more than just storage. You have all the APIs and stuff, and use it for metadata. You can really use it to support a lot of the applications that you're building. Cloud storage provides all the needed functions for users, and it also often allows a lot easier adoption by users. And FME then allows us the integration of existing systems via all those different APIs. So it minimizes the manual work and configuration and settings and automate. So I also want to give a shout out to our folks in our space management group, Roxanne Verdi and Nan Wang, who really basically helped us work through all of the getting things from the BIM model and how they wanted to get it for TRI CAD. Jason Venditti and Carl Larson from our design and construction management group, who helped us do all the utility work, and then Joe Balzano that helped us out with the sign inventory. So thank you very much. And hopefully I have still some time for questions. Great.
And if you could please repeat the question.
Yes, I will do that. Thanks. Yes, Gretchen.
Sort of a detailed question about when you were doing the doorways. Can you specify where you want that line? I noticed you have well, we do ours to the center line. So you can specify that kind of thing?
Yes. So the question was, how do you specify where the line goes within the door frames? And we, I guess, specify when the door is closed, that space is part of the room. So instead of going to the center line, we take that space in there. So you can get down to that level of specificity of which side it goes to.
And then how do you, during a renovation and you're updating the floor plan, do you update it in CAD, and how does that get pushed then out to the web service?
Well, basically, so the question is, how do we, after renovations, how do we push out floor plans to the web service? And actually, we don't put our floor plans on the web yet, which is part of why I was asking you the question earlier today, is we know that it's coming at some point in time. Our floor plans are really shared internally through a SharePoint site. Space management gets the changes that come from design and construction management or alterations, whoever has done the alterations, and then they will update the AutoCAD drawings themselves, and then they get posted up and shared on this SharePoint site.
So is that run through FME at all? Is that a part of the process?
That's not really part of FME. It's really that initial, how do we pull out from the deliverables of a new building. But rather than have, this was a process that took hundreds and hundreds of hours in the past for somebody to basically do all the polylining for the spaces and things like that. And now with FME, we've been able to, now that once we've got worked out the process, it takes, minutes to process. So it took quite a few hours to set up the process, but now we can modify it depending on what the deliverable is and what the names are and things like that. But now that we have the basic workflow set up, that's going to save us a whole lot of time in the future when new buildings come online.
Question. So Niels, how do you separate out spaces by height? So for instance, we're not allowed to count anything that's shorter than 6 feet as assignable space. Do you pull out any of that information?
The question was, do we pull out space based on height, and if there are any limits to that? And unfortunately, I do not know the answer to that question. Space management is within our group in campus planning, but I don't know the answer to that particular question. My guess is probably the same. You're right. I mean, if it's not an inhabitable space, but I don't think that's in the data that we have within TRI CAD. Basically, because in TRI CAD we're just dealing with the 2D floor plans and we look at square footage. I don't think we look at the height.
We found one the other day, and we're very fresh in our mind.
Okay. Any other questions? So is anybody going to think about using FME in the future? I have to say, it's made a huge difference in the way we do things, because we deal with so many different types of data from so many different divisions on campus. But then again, XY is usually a common denominator, and so FME allows us to integrate all of that data within our GIS. Because what we have found is, yes, TRICAD is our space data management system. That's the source of record for space data, and we have all these sources of data, but GIS is still one of the best ways to visualize data and provide access to it to a lot more people. So right now we're going through a process where a lot more and more people within our campus planning, design, construction management, and physical plant are actually utilizing this web-based GIS to, again, I find the most important part of it is as a communication tool, making sure that we're all working on the same database. And so, for instance, we have our complete tree inventory within this data, and one of the things we recently did is use the actual tree inventory program to create route boundaries around the trees. And so that's really important for the utility people to pay attention to. Of course, they're not too happy about it because now they can't just claim ignorance about, when they want to put a utility line in through here. So one of the other neat things about our online tool, which is a wonderful little program called the General Purpose Viewer, put out by Applied Geographics, or AppGeo, in Boston. And it's a stored procedures-based program. So it uses ArcGIS services that serves up all the GIS data, but then it has all these related database tables that store all the procedures on, all right, if I asked it this, it'll do this. If I wanted to do this, it'll do that. So it's a wonderful little program for an online, and it has a very easy-to-use interface, but allows you to have a lot of power in basically accessing the databases and doing a lot of queries and things like that. Well, one of the really cool tools it has in there is a markup tool. So that's one of the other reasons we wanted to get the CAD drawing out there in a graphic format, is so that our utility guys out there, when they come and find mistakes or things that need to be updated, they can actually mark that up and send it back to us and give us that markup. So basically, once they've marked it up, they basically send us a link to that markup. We click on that link, and then we can see it just brings us right to the same view that they were looking at. And then we can also capture those markups in a GIS database as well. So anyway, I hope you enjoyed it. So thank you.